Hi, we're on to question number 46, and this is a fun one. Again, we've covered all of the means to do this, maybe not super directly, but definitely indirectly, and you have the tools from a lot of the information that we've covered in the course up to now, and even just the second half. But let's dive into it and take a look at what we're looking at here. So, a 200 mast competitor in a strong person competition or a strongman competition is attempting to pull a bus, right? So, if just to give a little bit more context, here is my super very accurate bus. Here we go. We've got a bunch of little windows along there. Great, totally. That's a bus. Um, So we have the strong person and trying to pull this bus. You can see they have a harness on, and some ropes, and they actually do this. If you ever watch a strongman competition, so it's asking what is the frictional force, and they just denote it Fs here, and the normal force Ry. So we've in class typically gone. We'll just put like N F or something similar, but here they're just saying RY. That's fine, totally able to do that. Occurring in this moment, okay? So more or less what this is asking, what is those two forces occurring in this moment, okay? Now, one of the important things to have caught while you're reading through this question is that they are currently not moving. So if they are not moving, if you recall, that means they're in static equilibrium. So all the net forces, both on every axis, on like the XY, so linearly, as well as torque, right? So angular, rotational stuff, it's all going to add up to zero on every plane or axis that we look at. Okay. So if we take a peek here at the question here, we're given a bit of a free body diagram, but just to clarify again, frictional force is down here. Let's give it different colors. Hold up. Let's track along. Let's give frictional orange, and I kind of like using purple. So the normal force is in that pinky purple, okay? And so those are the forces we're trying to figure out. Now, thankfully, one of the nice things about this is we see that one is on the x-axis, and the normal force actually has y. So on the y-axis, it's written right into there. So we know that all the sums of the forces, let's say, so sum of the forces on x need to equal 0, and the sums of the forces on the y need to equal 0. Again, not moving anywhere. That was the big tip off there, okay? So again, on x, that's where we're going to find our frictional force somewhere in the mix, and our normal force is going to be on the y, okay? So here it says it's Ry, so that's our normal force. You can emphasize the R to see where that comes from, okay? So again, we're looking for 0 newtons and near 0 newtons. Okay, so how do we do this? Well, we start collecting. We start gathering all of our terms and see where they're coming from. Let's go for some sort of oranges and reds here for x-axis. So, Fs, or our frictional, is going to be one of them. What else do we have here on the x? Well, we have this here. That's given to us in newtons, force, so we're happy with this. And that's the tensional force of the rope, okay? So that's the pulling on the rope. They gave us a little direction here as well as the force. So, somewhere here we're going to need our 600 meters of tensional pulling force, right, on the rope. And anywhere else we have a horizontal? Well, take a look at this. We have an angular force that's coming down. So this would be rope. So again, maybe the bus wasn't best there. Let's chop that out. So it's going to be more here. So let's say that's the bus kind of there, okay? So I get rid of all this. Okay, so the bus is attached there. We can see that's causing a bit of a downward angle of that rope where it attaches to the front, probably the bumper of the bus that this person's trying to pull, okay? So if you recall, whenever we have an angular force or vector or whatever, we can split it up into x and y components, right? We've done this lots before. We do it when we are looking at torque, or we can do it when we're looking at yeah, lots of different things, okay? So to do this, we just need to figure out the x and y part. So to do that, we're gonna take our, is it 2,200, let's go, okay. So we're gonna take our 2,200 newtons, and in one treatment of this force to get one component, we're gonna go cos theta. And then in the other treatment of this number, what we're going to do is we're going to go sine theta, okay? And if you remember when we did that previously, or with other aspects of this course, or different variables that we're looking at to do with degrees or angles, is we end up getting our vertical and horizontal. So cos, recall, that will be our x, and this will be our y for sine. So it's always the case. Cosine is x. So from here, once we crunch the numbers, so our theta is 14 degrees, and we're going to plug that in. And once you calculate it out, what you end up getting, sure, I'll keep it. Let's go, let's blue. So you calculate it all out, you get 2134.6, which we could round up very easily. And then for sine, 532.23. Again, we're gonna round those up when we go to use them. Okay, so we got two more values here. Okay, so let's go back, and now we've collected all of our x. Okay, so we got that x accounted for in our equation, we got that x, and now we have this x, right? So we said that was 2134 point, well, let's just round up. I'll go 36, 5 newtons, okay? Great. Sorry, 21. Okay, so now that we have all these variables involved, for x, we just need to double check to make sure the direction of all of these is correct. We could have done that when we put them in, but I just wanted to get it all into this equation to show you that we're collecting all the x forces before we start sorting it out. And well, sure enough, we have a, let's say, rightward pointing frictional force, a rightward pull on the rope, but we have this leftward variable as far as the x component there. So we need to make that negative, okay? So what I'm going to do is, just to give us a little bit more room, oops, we've got some stuff coming with us. Okay, so we're going to do that. Let's make it a little smaller. Okay, so from this point in time, what we want to try to do is isolate that to be its own variable, right? Well, or sorry, we could do that, but it's actually probably going to be easier if we don't. So if we just go like this, so I'm going to clean this up just a little. Okay, so if we essentially move these variables to the over side, so we can actually crunch the number first, and what we get is, sorry, I'm just going to state that whole thing over again just to make sure it's nice and clear. Sorry. Yeah, let's write it this way. Okay, so again, if we end up calculating that aspect, what we end up getting is 1485, okay? Right, and then because all of this is still technically equal to 0 newtons, because we want that to balance out, right? So we're just carrying that over there. What we want to do is actually migrate that negative number over, so we add that to both sides. So what we end up getting is our frictional force is operating in a positive direction at 1485 newtons, okay? And that kind of makes sense, right? So if we look at the orientation of that arrow, positive, that's what we were keeping it. We said that was negative. So this makes sense. That number makes sense. We're happy with a positive number there. We got our frictional force. Okay, great. So that's 1 and 2, right? We still have one more to go. So if we look here at our y-axis now, let's try to count everything there. What were we going with? Purple. Okay. So again, we're trying to find our normal force. So take a little peek. So that's Ry. And what other vertical forces do we have? Well, we have weight acting downward. That's the weight of this person's body. And in particular, we see something being pulled back. So again, we got this angular force occurring here, but we've already discussed and figured out a way to get just the vertical part of that, okay? So the downward part of this angle is 532 newtons, okay? Great, and so then we can add that in, right? So we're collecting values. So again, up here, one of these is weight, and then the other one is, let's say, it's just a tensional rope force on the vertical axis, so we'll just put in the number, okay? So now we can actually put in the numbers. Again, 200 kilograms. Well, really what weight is, right, is mass times gravity, right? So if we're carrying all of this through, just to help for clarity's sake, y. Okay, so we're carrying this through. What we get down here, once we clunk in our mass, which is 200 kilograms, sorry, that's 200 times 9.81 meters per second squared, plus 532 newtons. Right, we're going to calculate that all. And what do we get? Well, we get Ry plus, did I calculate that out? Yes, it looks like 249.4, and right, the other part is if you're talking about vertical and the up being positive and the down being negative, what we actually would have had here, sorry, was negative values, which is fine. It just means this is negative. Doesn't change the math aspect of that really much. And what we end up getting after we flip our values around here, right? So we know, leave our y there, and we move, so we add, we're going to add this amount to both sides. We can say Ry equals a positive 249.4 newtons. Okay. And again, I just want to be really clear about that. Sorry, I feel like I kind of skipped. So what you can do again, if this is equals, so 0 essentially, our normal force minus 2,494 newtons. To get this onto the opposite side, of the equation, you add that to both sides, okay? And so I added that to both sides, and then flipped it for convention's sake, okay? You could have left it on the other side. Okay, so here's our final answer for our normal force and our frictional force. And again, just to double check the normal force, is this heading upwards? Yes, that's positive, upwards. This normal force is heading upwards. It's a contact force perpendicular to the surface. So yeah, all of this gives us the warm and fuzzies. We like this. This is a good answer. We're going to keep that. And yeah, that's that question. So yeah, essentially the problem solving steps to this was collecting the X and Y axes. Once you're able to do that, just discerning each force that is occurring. And then once you have each force on the two axes kind of sorted out, you solve for the unknown by more or less making sure you mark your conventions on your system, and then working through and isolating the variable at the end. Okay, great.